Right now, somewhere in the world, an arrow is flying through the air. It left the bow. It's heading for the target. It's moving. Except, according to a Greek philosopher who lived 2,500 years ago, it isn't. In fact, he could prove that nothing in this universe moves. Ever. At all. And here's the unsettling part. 2.5 millennia later, we still can't completely prove him wrong. This is Zeno's arrow paradox, and once you really see it, you can't unsee it. His name was Zeno of Elea. He lived around 450 BC, and he made a habit of asking questions that drove people insane. Most of his paradoxes are about distance. Achilles racing a tortoise, crossing a room by halving the distance forever. But the arrow is different. The arrow attacks something deeper. It attacks time itself. Here's how it works. Picture an arrow in mid-flight, frozen in your mind for a single instant of time. Just one snapshot, one indivisible moment. In that instant, ask yourself a simple question. Is the arrow moving? Now think carefully. In a single frozen instant, the arrow occupies exactly one position in space. It's right there. It can't be moving to somewhere else because we're talking about one instant. Movement requires going from here to there. And in a single instant, there is no there. There's only here. So in that one instant, the arrow is motionless. Okay, fine. So zoom out. Take the next instant. Same thing. The arrow occupies one position. It is motionless. And the next instant, motionless. And the next, motionless. Here's where your brain starts to itch. Time is made up of instants, and in every single instant, the arrow is not moving. So when, exactly, does it move? If it's motionless at every moment that exists, how does it ever get to the target? You probably want to say, well, motion happens between the instants. But there is no between. That's the trap. Instants are, by definition, the smallest units of time. There's nothing between them, the same way there's nothing between two consecutive integers. So you might try, okay, then time isn't made of instants. It flows continuously. But now you have a different problem. If time is continuous, what does motion at a single point in time even mean? You can't define velocity without comparing two different moments, which means at any actual moment, motion isn't really happening. It's only happening across moments, which is exactly what Zeno said. Motion is not something that occurs at a moment. It's something we infer between moments, which means motion, as we experience it, might be a kind of illusion stitched together by our minds. The arrow doesn't fly. The arrow exists at one position, then another, then another. The flying is something we add. Now here's where it gets really wild. You'd think modern physics would have demolished this paradox by now. Calculus, relativity, quantum mechanics. We've come a long way since a guy in a toga was confusing people in the agora, but the arrow still hasn't been fully solved. Calculus gives us tools to describe motion mathematically. Instantaneous velocity, limits, derivatives, and these tools work beautifully. They put rockets on Mars. But notice something. Calculus describes motion. It doesn't explain how it actually happens at a single instant. It just defines a value that works. Quantum physics goes even further. There's an effect literally called the Quantum Zeno Effect, named directly after this guy. It shows that observing a quantum particle frequently enough can actually freeze it in place, stop it from changing states. The universe, at its deepest level, seems to behave a little bit like Zeno warned us it would. So what do we do with this? Zeno wasn't really trying to claim that arrows don't move. He was a student of Parmenides, and they were making a much bigger argument. That reality, as our senses describe it, can't be trusted. That logic and experience point in opposite directions, and when they do, logic wins. The arrow you see flying is real, but the flying might not be. What you call motion might just be a series of stillnesses blurred together by a mind that needs a story. The next time you watch something move, a car, a bird, a falling leaf, try this. Imagine freezing it, 1 instant at a time, each frame perfectly still, and then ask yourself, gently, where did the motion go? Maybe it was never there to begin with.